that we decided that I would make a better Princess Leia. I always like putting awkward sentences into the first part of the recording. Somebody goes, the first thing he said is, I thought I would make a better Princess Leia.
Fit with the conversation.
That's right. All right.
We just like giving you no context.
Let's see. All right. So last time, as we were going through this, and somebody remind me at the end, like 5 minutes before we're done, I have an assignment I want to give you, so I don't want to forget. So I'm grading it whether I give it to you or not. So just that's the threat. Okay. So last time we had finally gotten down to the point where we were able to look at the current transaction and see if we were one of the recipients. So in the end, we went through all the recipients for, this was transaction 0, which from our Blockchain.info. I think was us receiving a bunch of money. Well, a little bit of money. Yep, so this is transaction 0. And when we clicked on this guy, here, we see that we're one of these transactions in this big collection here. Okay? Adding up to the 24.62 something or other. All right. So now, and the way we got at that information is we went ahead and we grabbed all the transactions associated with us. That's our URL. So for the voting thing, we would pick the, our wallet address. We would pick the address associated with the candidate that we're wanting to count votes for. We open up the URL, blah, blah, blah. We parse it right here. We get the array of transactions. That's in a variable called TXS. Then we get the out part of that array of transactions. Let's see, the transactions is right here. Actually, we don't even use this, do we? Just streamlining it because I want to put this into some other objects today. So out should hold the out key of the final transaction, blah, blah, blah. So transaction 0 is the transactions at bucket 0. Transactions be read in right here. So that's the array of transactions. So we'll get the very first transaction. That's a JSON object. And that's going to get us basically this guy. Transaction associated with this guy right here. Then we'll get all the recipients of that transaction. So since this particular transaction was something where we were on the receiving end, we should find ourselves somewhere in the out. Okay? Now, for the voting thing here, if we're trying to implement initially the counting of votes, we're not interested in whether or not we sent Bitcoin out. We're interested in Bitcoin that came into us. That make sense? So we're going to go ahead and for every single transaction, we're going to grab the out. And we're going to go and find our address in that out, assuming it's in there. It will be in there for every single transaction where we were the recipient. It will not be in there if we were the sender. So, for example, we go back to transactions. In this case, we're the sender of this guy. So in transaction 1, we would find ourselves in the inputs, but not the outs. And that's a short, what prints out right now? Are we just showing just ourselves? this is printing out those keys. So that's all of our variable names. We'll leave those. We might need that. And what we're going to do is running this one more time real quick. Okay, so that's where we found ourselves in there. So down here is where we went through all the recipients. And we found somewhere in there, we were checking to see if the current address we were interested in was equal to our address. And if it was, we printed out the address and how many Bitcoins we sent. So for transaction 0, we see that we showed up in there. And I'm going to go ahead, I'm going to print like a extra little statement at the end that just says done. So we know when all the work's done, because we intend to go and look at transaction number 1 and see that we should see done before we ever see our address. Okay, so there's the one transaction it found of us in the outs, and then it told us we're done. So now if I go and look at transaction number 1, where we were the sender, we should not find ourselves in the recipients. Okay, so there's the done. We weren't in the recipients anywhere. This is all the variables up above. Okay, so for a given address, if we're looking at the address for our candidate, if we look at all the transactions and we look at all of the recipients of those transactions, every single time we find our address, at least the address associated with an individual candidate, keep in mind that we can choose, let me see if can I simulate this? I think I can. I'm going to go into the wallet, which is here, and I'm going to say receive money. I'm going to create a new address. All right, we'll say candidate 1. Okay, so went ahead and it created an address for us here. Now, what we're interested in, let's see, we're going to have to test this, so we should probably go ahead and do this right now. Okay, I do have 0.01 Bitcoins in there. So I'm going to go ahead and I'm going to get this address. This is our candidate 1 address. And I'm going to go ahead and I'm going to send some money there. That's a Satoshi. 4, 5, 6, 7, 7 zeros and a 1. Okay. Oh, it didn't even send it out in the blockchain though. Okay, I got to go in through a different. I want to find out if we can just check our global address or if we have to check each individual candidate address for counting. Or can we just check, the polls address and inside there accumulate all the ones that went to candidate 1, all the ones that went to candidate 2. I want to know how their data makes things show up. Okay, 0.05 Bitcoin is there. So let's go to Can't I send? Why is it not clear how to send? Oh, is it under fund account maybe? Back under balance?
The tab that you just click transactions. Go back to
Oh, I get it. Here,
what are you trying to do?
I want to send, I want to withdraw.
Yeah.
Withdraw Bitcoins. So we're going to send it there. That's funny, they're going to take a commission off of all right, well, we'll send that.
Just in case it's not you saying that 0.001 bitcoins.
Right. A confirmation email's been sent. Oh my gosh. These guys mean
This is
business.
better than a bank.
Funny you should ask that because that's related to a homework assignment. The one I told you to remind me to give you that I was grading whether I gave it to you or not. So I click the link and then that makes me log in again. It's okay, you got this.
It's gonna want your two-factor authentication.
That's right. Step 1, collect underpants. Step 2, Step 3, profit.
Wait, what?
That's isn't that from yeah, just no, it's the underpants gnomes. Wasn't that South Park?
I don't know, I haven't seen that.
Oh. Similar voice though. All right, processed. In theory. All right, so should be able to close this. Go back to wallet, which I'm sure is timed out by now. Which I'm okay with that. I'd rather it time out be a little. Okay, this looks like it's the new one, right?
Yeah.
There was no confirmations yet. It actually showed up shockingly fast. Yeah, that's not it. That's these two together. Isn't it?
Hmm.
This was the,
Commission though, remember?
yeah, this was my commission. So this should have been paid to somebody else.
remember?
Right, but I actually sent that. So this should be the, oh, I tried to send to Satoshi.
Yeah, remember, and it said move between wallet.
Yeah.
The one that says move between wallets still.
But didn't I send something? Oh, that was the smallest it would let me send, not a Satoshi. Because that's not 7 zeros and a 1.
Yeah.
So this looks like it is that new transaction. How the heck did it get in there so quick?
Small enough that they just said, sure, if it's fake, we'll pay for it anyway.
Well, but this is on blockchain. I sent it from CEX. So I sent it from here, which should have created a transaction, added it to the current block, gone through the mining process. It should have taken up to 10 minutes.
Maybe that block got mined right away.
You have to be pretty lucky, I would think.
You find your own block.
Okay, well, we can at least compare the addresses. So if I go over to CEX and I go to,
I think that's your transaction because you had more in your balance. You had like $3.98 before, and now you have like $8.
well, this is the amount I just sent, which is fine. Let's go to trade, let's go to fund account. So this should have been, actually it'd be interesting. I wonder if it actually comes from my address at CEX or CEX holds my balance and sends it from some address that they have.
I would think it would be your address because you can put money into it by your address.
So SUPR, super. That's like Elite Speak Super. I like that. That should be a WoW name. Okay. Let's see.
It's already taken.
You think?
SUPI.
Look at this transaction.
It's a good question. I suspect you can do one, but good luck getting the one here right.
Yes, this is interesting. So this is the address that it's sent from, which is not my address. This must be CEX's clearinghouse, this guy here. And this guy sent two payments. He sent 0.0099 to me, to the address I told him to send, what, 0.012? And then he sent the rest to WXFH, which I'm assuming is their address for commissions. Oh, it looks like they created an address just for that commission. Well, that can't be right. Relatively unimportant with what we're trying to accomplish right now. What I want to look at now then is we want to find this address in our transactions. So go back into our code. We'll replace this guy with the address we're looking for. Now remember, we're initially getting all transactions associated with our wallet address. That is, from our voting thing, the clearinghouse wallet that should have all payments coming into it. We're hoping that as part of those transactions, well, not necessarily hoping, but we're checking to see if as part of those transactions, it gives us the sub-transactions that go to the sub-wallets within our global wallet. So that means that, is this guy listed as a transaction right now? My transactions. It'll be interesting to see if this one shows up yet, since it's unconfirmed, or do only confirmed ones come up? So let's go ahead and look at transaction 0. And then let's just print out every single address, every single recipient for that transaction. So there should be just one for 0 if it works the way we're speculating. But since this is an unconfirmed transaction, it's possible this guy shows up as 0, in which case we should get a big long list of transactions it's sent to. So we're either going to get a giant list of transactions, or we're going to get 2 recipients. Whether or not it's a confirmed, whether or not it gives us unconfirmed transactions. All right, so let's go ahead and run this. Yep, just 2. Okay, and that's good. And we're looking for AV7F. Yep, that's our transaction. So it does come to the clearinghouse. That's good. Run it again and should show us that one transaction. Just so happens we sent it from a place that has a transaction fee from a pool. So I try to take money from you as much as I can, both sides of the transaction. I think that CEX takes a flat transaction fee. So whether you're sending 1,000 Bitcoins or 1 Satoshi, it takes a flat transaction fee. So we probably weren't too efficient with our coins there, but whatever. Okay. So we can use our one clearinghouse wallet for all of our candidates, and we can create a different candidate for each one of these things. And then we can look for counting for our different candidates. Now, bucket 0. It's bucket 0. Let's look at transaction 1. Hopefully it's still unconfirmed. Okay, that's us. Sending Bitcoins to another wallet. That's this guy. Oh, it did all that internally. It never hit the blockchain.
Shouldn't it have to hit the blockchain now if you're moving between wallets?
But it's based on the way this is working, these aren't wallets. These are unique identifiers for payment. Keeping in mind that this guy here, our wallet, knows about all of our receive money addresses. So when he goes and he scrapes the blockchain looking for all transactions that are owned by us, he'll look for all transactions that were sent here, all transactions that were sent here, all transactions that were sent here. So keep in mind, this is not a real place. This wallet's not a real place. It's just a unique identifier on the blockchain. So when something gets added to the blockchain with this end address on it, we just say, okay, here's some coins that left this guy and went to this address. Confirmed, not double spent. Now, having said that, if you try to send coins to an illegal address, like if you just make up a hash and it isn't actually owned by anyone, it will not go through. It won't be verified.
How do they know if it's owned by someone?
When a wallet is first born, it is added to the blockchain. No data is associated with it, but it's still added to the blockchain as a valid wallet. Blockchain holds other pieces of information other than just transactions. So when we created that secondary received money code, it had to have added that to the blockchain as a wallet. Otherwise, this transaction would have failed. Since this transaction didn't fail, Blockchain.info must be checking all of the wallets on your behalf.
So then when we're looking at the blockchain, it should have just appeared as a wallet.
Well, no, when we're looking at the blockchain, we will see a payment, an entry associated with this guy right here. It's an unconfirmed entry right now, so it was temporarily added to the blockchain, but if it ends up not being confirmed, it'll roll back. So it seems like we do have 3 separate wallets here. 3 separate physical wallets the blockchain knows about. Blockchain.info goes ahead and manages our global wallet as the container for all of our sub-wallets. So we can search it as such. But physically, it is a separate wallet on the blockchain. An interesting issue with that, though, is how many transactions does this actually ever support? So that's the wallet address. How many characters in this? "34 characters, where each character can be 0 through 9, A through Z, upper or lowercase. That's 26, 52, 62. So that's 62 to the 34th power unique transactions. That's a lot of transactions, but is that enough transactions?
You mean enough addresses?
Correct. This is if every single payment that ever occurred came under a unique address.
Oh.
So rather than me just giving you my wallet address, so every payment that you make to me goes to this one wallet address, this would be if every single payment that's ever made on the blockchain always goes to a unique address that's owned by somebody.
I would say no. 8 to 60. Kind of big.
So let's divide this by divided by 10 years, 365 days in a year. "24 hours in a day, 60 minutes in an hour, 60 seconds. That might cut it. That's 2.77 blah 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 with let's just say 47 zeros after it or something like that. Number of transactions every second for the next 10 years. That probably covers it.
Yeah, I got it.
I don't know. It's interesting to me.
I wonder how many.
Well, I can tell you the number of transactions that happen every single day right now. Let's see. Can I? Oh, here's network. Oh, maybe I can't. Well, it's a lot though. I think this probably will cut it. Just seemed like it maybe wouldn't. So in any case, I think this new wallet address is getting added to the blockchain. So the actual blockchain does become aware that something was sent to a legitimate wallet address. And then Blockchain.info just parses the blockchain on one of its users' behalf for all of the addresses under their wallet to show them all their transactions. And more importantly for us, their API then gives us those transactions under a single wallet address. Interesting thing we can do here. I wonder if there's synonyms for each other. So if I paste in that new wallet address up there, let's see if it'll treat that as a top level. Okay, so it saw that first one. Let's just do, let's take the if statements off and just print all the transactions again. I'm going to do this for transaction 4. Let's see if it treats those addresses as synonyms. No, array index out of bounds error. Okay, so what that tells us is we can hit their API passing it one of our sub addresses, and it will give us only the transactions under that specific address. But if we pass it our top level address, it'll give us all transactions that have occurred with that one or the wallets that we created under that one. So just kind of information about how Blockchain.info works. All right, fair enough. Okay, now what we need to do is we need to start creating objects to make this look a little nicer, because right now we just have a jumble of code now that we figured all this out. So we're going to want to have a counter. So we're going to start off, create a new class, and we're going to call this a vote. Actually, let's call this an election. All right. So what's an election? An election is a collection of votes. We don't know how many votes there's going to be, but it'll be a collection of them. All right.
Keys just aren't working today.
All right. So an election is a collection of votes. A vote is let's call it a wallet address and an amount for right now. For right now, we're just going to count it as anything to that specific wallet address counts as a vote. We can, through these objects, we can add in some other error checking for that later. But right now, we can't necessarily rely on it, seeing as though the way we're sending Bitcoins has the transaction fees. So if we try to send 0.01, not actually 0.01 gets sent, something smaller does. But I'm sure in the implementation, we would pick a Bitcoin wallet that can send stuff to the blockchain that doesn't have transaction fees and all that jazz. So we'll just assume that everything's legit. We don't have anybody trying to cheat the system in our voting thing. Okay. So we have a wallet address associated with a vote, as well as the amount of that, which is relatively inconsequential, but we'll go ahead and capture it anyways. Okay. So let's go ahead and build our vote object as well. So have a private string wallet address, and a private double amount. Good enough. All right, that'll be our starting point for our vote object. And then our election is going to have a collection of votes should be a linked list of votes, import java.util. Okay. The constructor for our election should probably also take a base address. And then I'll put a comment in here to do parse base address for votes associated with a candidate. All right, good enough. Okay, so I'm going to leave that there for now so I can give you your homework assignment. And this deals with the security of the authentication side of our project here. This is 390. So we need to have an authentication portion of the voting system that mimics authentication used by places like banks. Write a 2 to 3 page paper which describes the various processes that banks use for authentication. Suggest one that is most appropriate for our voting application and argue why it is the best for us. Make sense? So We almost went through kind of a little bank-like example today where in order to even log into CEX and do a transaction, I had to jump through 3 or 4 different hoops. So whether you choose a bank or you choose something along those lines, we need to have an authentication system for the actual casting of the vote side of things that lets a voter prove they are who they are. Just like we want banks and stuff like that to know that we are who we are before they let us start taking money out and that kind of crap. Okay? So that will be due on Wednesday. We'll pick up from here then.